Alright, welcome back to this week's coding task, where we'll be looking at OSHA data, which is the Occupational Safety and Health Administration, which is part of the United States Department of Labor. And they basically require a lot of employers to keep record of some serious workplace injuries and illnesses. And we prepared a dataset for you, which you can download from our website, going to the Resources tab, and then down to the Tasks section. And here is basically everything you need. The dataset itself, as well as a data dictionary containing some variable descriptions, and the PDF with the actual tasks themselves. So let's get started. And first up, I'm going to create a new project for our files to live in. So go to New Project here. And I already made a folder where I put the dataset. So I'm going to choose Existing Directory. And I'm just going to browse for the folder. And then click Create Project. And here you can see I already put the dataset in here, which you'll need to do as well. And first up, I'm going to create a new R Markdown document, and I'm going to call it RUCtask. And here, the default output format you can leave to HTML, that's fine. So let's remove this default code here. And as a first step, we are going to load the libraries we're going to use, which is tidyverse on the one hand, as well as tidytext. And if we run that, you can see we're getting output here in the middle of the document, which is not very tidy at all. So let's turn that off by going to the settings menu and choosing chunk output in console, which is going to put all our output on the right here into the console. And so we can move into the first task, which is going to be to load the data and to have a look at it. So we're going to save our data into the OSHA variable by the read CSV function, as it's a CSV. And here our dataset already is in the right location, so we can just choose that, load it in. And using the glimpse function, we can get a first look at what we actually have in here, if we spell it correctly. And here you can see we have a bunch of columns on the firms themselves, the kind of industry they're in, as well as a bunch of columns on the injury and the illness types they recorded. And that was already it for task 1A. So in task B, we are going to check for missing values in the data. And one way to do that is to use the column means function, which is going to allow us to do a percentage value of missing values in each column. So if we put the isNA function in here, we can see that in the worst case, we have about 8% of missing values here in the company name column. But this also contains some columns that don't have any missing values at all. So just to get a better look, let's filter out these unproblematic columns. And to do that, we first pass it onto the endFrame function to put it in a nice data frame format. And then we can filter for values larger than 0. So here we can see basically 20 of our columns have some missing values, but they're pretty close to 0%, so that shouldn't be too much of a problem. Now, moving on to task C, we are checking our understanding of some of the data. So having a look at two columns, namely no injuries, illnesses, as well as size. we could have a look at the data dictionary that we provided for some in-depth description of these values. But for now, we're just gonna check how they're looking, how many injuries we have, how many big and small companies we have, and we can do that with the count function. So if we pass our data frame to the count function, we can say we want to count no injuries, illnesses, and we're going to sort by the most frequent of values. So here we have two categories, one meaning no injuries or illnesses recorded at all, and two, some injuries recorded. And over the 6 years in our data set, we have roughly 600,000 incidents recorded. And we can do the exact same thing for our size column to have a look at the company sizes in our data. And we can see that the category 2, which is sort of medium-sized enterprises with less than 250 employees, we have about 1.2 million firms in our data set over 6 years. So moving on to task D, we're going to have a look at all our columns here in the middle, which contain the injury and illness types. And you can see all of them contain this word total. So that gives us a selector to choose these columns. So instead of typing them all out, we can just say we want to look at all the columns that contain the word total. So let's do that. Using the select function in here, we can say contains, and then we're looking for total underscore. And we can pass that on to the summary function, which is just a handy shortcut to get some distributional information on these columns. And we can see here the quantiles of each of our total columns, as well as the missing values. So for task E, we are going to create a new column that we're going to use later, which contains the total cases. So we have a bunch of different injury types here, but no column that contains kind of a sum of all these different injury types. So what we can do is use the mutate function, and I'm going to save that back to the original dataset as we're going to work with the new column we are making. So mutate, and then we can say total cases should be the sum of all these different columns, which I'm just going to copy from the tasks. So total deaths, days away from work, etc. So this is just going to add a new column, total cases, which we can keep on working with. And finally, for task F here in the first task, we are going to filter out the very smallest companies, and we just define this threshold as companies with less than 10 employees, so that these micro companies don't distort our evaluations that we're going to do. We're just going to filter them out. So again, because we're keeping on working with this data set, I'm going to save it back, and I'm going to say filter for annual average employees larger than 10. All right, that's it for task 1. So let's move right into task 2, where we're evaluating some of the columns we just created. So for task 2A, first we're creating 2 additional columns, cases per employee and deaths per employee, we called them. And these basically just contain some relative values of these injury types or deaths even per employee, so we can compare some different size companies. So again, we can use the mutate function to make new columns. And in here, we're going to say cases per employee should be the relative measure of the total cases column we just created over the annual average employees. And then a second column, deaths per employee, that should contain our total deaths, also in relation to the annual average employees. And once we have added that, we can move on to plotting this data and getting a first look. So let's pass our OSHA dataset to the ggplot function. And here in the aesthetics, I'm just going to define the x-axis as we're going to do a histogram. And on the x-axis, we're going to look at cases per employee. So once we have defined that, we can add a geom histogram. And to have this be the right size, we're going to define the bin size. And we're also going to give it a fill color, which is going to define just the color of the bars. So I'm going to do a royal blue here. And we can have a look. So right off the bat, we can see that most companies actually don't have any cases per employee at all, or just one. And we also have some outliers here on the right probably, which is why our graph is going all the way up to 20. But because they occur so infrequently, we cannot even see them. So, and we're going to deal with that in the next task. But for now, let's just beautify our plot a bit by adding some labels. So with the labs function, we can define a title. And we're just going to say OSHA cases per employee. In here, we can do a subtitle as well, where we provide some additional information. So we could say, for example, we have some big outliers on the right. Now, both the X and Y axis are not that granulated at the moment. And on the y-axis, we have this scientific notation, which is kind of hard to read on the first glance. So what we can do here is change the scale x continuous, since there are continuous values. And one thing we're going to do is we're going to change the way the labels are plotted by using a function of the scales package, which is called comma format. And we also want some more axis breaks between these 5 case steps. So we're going to define breaks should be 1 through 20. And we can do the same thing for our y-axis. Now here, we also want this nicer format for the labels. So again, going to use scales, comma values, or comma format. And since I don't want to type out the breaks here, I can use a sequence. So for the breaks argument, we're going to say sequence from 0 to, just about 1.5 million. And for our step size, we want 250,000. And if we have a look at that, that already looks much more readable here. We have some granularity on the x-axis, and this plot looks a lot nicer already. A basic step we can also do is to add a theme. So if we add the minimal theme here, this gray background goes away and we have a much nicer plot. So now let's move into task B, where we're going to deal with our outliers here that we can't currently see. So let's make a new chunk here. And so first up, we want to know how the distribution looks like. We can already see that most companies probably have 0 or 1 cases per employee or something in between. But let's see just how unbalanced kind of this data set is by first making a new column to evaluate. So using the mutate function again, we can make a column more than one where we filter out companies that have more than one case per employee. And we're going to count how often this occurs. So let's count more than one. And we can see that the vast majority of the companies don't have more than one case per employees. So we're going to look at this large part of our data set. And to keep on working with just the companies that have less than one case, we can use the filter function. And I'm going to save that back to the OSHA variable. So let's say filter, and our cases per employee should be less than one. So now we have removed all of these large outliers here. We can plot this data again, and we can reuse a lot of this code above here, except for our subtitles describing some large outliers. And well, let's have a look. So because we removed all these outliers, we don't need these large axis breaks. So we're going to go to a 50,000 step size, and we can see a much more granular distribution here containing most of our companies in the dataset. So moving on to task C, we are interested in how these cases develop over time. And as we saw in the beginning, we have about 6 years in our dataset. And if we group our data by this filing year variable, which is called year filing for, we can evaluate the cases per year. So we're just going to do mean and median cases. And to do that, we can use the summarize function to create some summary columns. So we can say mean cases should be the mean of cases per employee. And we're going to have to remove missing values here so that our mean function actually works. And the same for median cases with the median function. And also removing missing values here. And we're going to have to spell that correctly. So now we have some grouping statistics on our data, and we can have a look at it. We already get what we need here, but not in the format that's best for plotting. So currently we're in the wide format. You can see one column per variable that we calculated. And to remedy that, we can pass on this dataset into the pivot longer function. And the only thing we need to specify in here, well, normally it is which columns to actually pivot longer. But because we want to pivot all the columns except for the year column, which is kind of our row dimension here, we can just say, instead of which columns to pivot, we can also say which columns not to pivot, which should be year filing for with the minus in front here. And if we have a look, this is much more suitable for plotting. We have our variable name here and the actual value. So now that's in the right format. Let's do a plot. And on the x-axis, we're going to have our year of filing, so year filing for. And on the y-axis, we're going to have the value column here, the numeric. And we're also going to have a grouping variable, which we're going to pass into the color argument, which is going to group the name column with our either mean or median into their own color. And color just means the outline or the line color. So we can add a geom line here. And let's do a geom point as well, which is going to give us a point for each value each year, as you can see here. And right off the bat, that looks pretty close to what we actually want. Just some beautifying steps again. We can add a title saying mean and median values, or median number of cases per year. And because our X and Y axes are pretty self-descriptive, we're gonna remove the Y axis label entirely, and actually let's leave the X axis label in here, but just a more pretty and readable value, like so. And also this title of our legend doesn't add much, so let's remove it. Also add a theme minimal, and we see the evolution of mean and median cases over the years in our dataset. So for task D, let's use this year variable again to get some information on the different types of injuries and illnesses. But this time we are going to plot a normalized statistic, so for each year which percentage of cases that were recorded are a certain type of injury. And to do that, we're first gonna select just the columns we want to have a look at, which again I'm going to copy from the tasks here, and these are just some of the injury types: poisonings, hearing loss, etc. So if we have a look at this, of course, wide format again, to plot it, we're gonna convert that to long format using pivot longer. And again, we're going to pivot everything into longer format except for our year variable, using this minus here in front again. And if we have a look at that, one thing that's obvious here is we have this total underscore in front of all of our variables, which doesn't add much in a plot. So we can remove this by changing the name column with mutate. So I can say name should equal the value that's in there currently, but without the total. So we can do a string replace, and in our name column replace the pattern total underscore with nothing. And we can see here this is a lot more readable. Now, to have a normalized value, or these percentage values per year, we can use the count function. So let's pass our values per filing year and count by name, so by type of injury here that was recorded. And as a frequency weight, we are using the value. So what that gives us is just the number of occurrences per year per injury type that we can use to make a relative measure. So first, let's group our data set by year. And now we can make a new column containing this relative measure with the mutate function. And for simplicity, we're just going to call that n. And n, again, here from the count function, we're going to convert that into the relative value of total cases by year that we grouped here, which is going to give just the percentage values in each year. So in 2016, the percentage of hearing loss cases was just about 1% here. So because we want to keep on working with this data, we first have to ungroup it again. And we can pass that to ggplot. And for our aesthetics, we're going to say on the x-axis, we want this percentage value of cases. On the y-axis, we're going to have the type of injury. And we want that in an ordered format. So we want the name column, but we're going to pipe this into a sorting function. And we want to reorder within each year. So we can say reorder within by this n value, so most frequent to least frequent, within each year filing for. And we are going to make our plot a geom column, which is basically just a bar plot, but turned by 90 degrees. And we can specify in here our fill color for our bars. And I'm going to use royal blue. So having a look at that, it currently puts, we have to correct values, but it puts all of them into one plot. And if we want subplots for each year, we can use the facet wrap function, and a facet is just a tidyverse language for these smaller subplots. So down here, if we go facet wrap and specify the variable we want to separate the plots by, which would be the year in our case. This is gonna separate all of the years into different subplots. And one more thing we're gonna say here is scales should be free, so they don't necessarily have to share the same axes. And here we can see we achieved our goal, but the plots are kind of squished. So instead of having 3 columns of subplots, let's have 2. And we can specify that with the ncol argument here. And now we can see a lot more of our data. So just a couple steps to beautify again. On the x-axis, instead of having these decimal values, we want the percentage values. And here we don't need the year in this y-axis labels because we already have it up here. So we can do scale x continuous first for our x-axis, and we can use another function from the scales package, which is called percent format, which is going to give us percentage values. And we also specify that the limits should be 0 and 1, so we get the 0% value here as well as 100%. And for our y-axis, we can go scale y reordered. And what that's going to do is, we can see it's going to remove this additional data that was introduced here by the reordering and go back to just the original names we had. So just for some optical aesthetic things, let's add a theme. I'm going to add the theme minimal, and we're also going to remove the x and y axis labels with the labs function. So x should be null, y also. And that's just going to remove our outer axis labels over here, not the small ones, because these are part of the facets. And we can add a title as well, saying normalized types of injuries. And we can move on to our final task, which is going to be to look at the most dangerous industries as counted by the deaths per employee here. And to do that, as you might remember, we have these industry codes and description in our data set, and we can use those to group our data. So grouping by industry description, we can do some statistics by each of our industry groups. And just as above, we can use the summary function to pull out a mean for each of these groups. So going summarize and mean per employee, again relative to have more comparability. You can say mean of deaths per employee, removing the missing values. And one additional thing we're going to add here is just a column with the actual companies within each industry group. And that is to control for the very smallest industries. So maybe in our data set, there are some industries containing just a couple of firms. And if we have some outliers there, if we pull a mean over that small industry, that's going to distort the actual danger of that industry by just having these outlier companies in them. So we can use the n function, which is going to count the occurrences for each group. So that would be the companies in our case. And in the next step, we can add a filter which removes our very smallest industries. So we are just going to put a threshold of 500 here, saying any industry with less than 500 companies operating in them, we're going to remove, because again, that could distort our data set. So if we have a look at that, that leaves us with over 400 industries still, which are some of the largest. And to plot only the 10 most dangerous, what we can do is we're first gonna arrange the data set. So that's a sorting function, and we want to sort by the descending mean deaths per employee. And we're just gonna take the top 10 off the top here with the head function. So seeing here, we can see that structural steelwork seems to be quite dangerous. And we can plot that in a column graph by piping it into the ggplot function, adding some aesthetics. So for the x-axis, we are going to have our mean per employee statistic. And on the y-axis, we're going to have our industry description. Again, here we want to sort from the most dangerous industry to the least dangerous. So how we can do that is by converting our industry description values into a factor first, and then passing this factor on to the factor reorder function. And we want to reorder by mean per employee. And adding a geom column with the bar color set to royal blue again. You can see how that looks. We have a nice ordered column plot here. Now let's just add some labels again. So for a title, I'm gonna go the BuzzFeed route and say top 10 most dangerous industries. And in a subtitle, let's add what we actually did. So we pulled out the mean deaths per employee per industry. Let's also remove the X and Y axis labels again, because they don't add much information here. So X and Y equal null. And one more thing here, again, we have the scientific notation on the x-axis, which is totally fine, but maybe not the most readable. So just as before, we're going to change the x scale, which is continuous, and I'm going to say the labels should be in comma format. And also add a minimal theme. And that looks pretty good. All right, so that was already it for this week's coding task. I hope you learned something, hope it was clear. If you have additional questions, comments, feel free to reach out to us via the WhatsApp group chat or via Instagram, and we look forward to hearing from you. So, hope to see you next time.